What's going on, everyone? Welcome back to another episode of the Muscle Memoirs Podcast. Today, we have a fascinating episode for you. Across the screen from me, Dr. Gil Carvalho. Dr. Carvalho, how are you doing today?
Doing great. Thanks for having me.
Yeah, it's my pleasure. Recently on the show, we had on Nick Hebert, the Nutrivore, on Twitter, and we had a comprehensive discussion on the role of saturated fat in the diet, talking about threshold effects. We also broke down polyunsaturated fatty acids and this fascination with demonizing seed oils. So I think this episode is going to play off of that really nicely as we get into a breakdown of lipids, understanding these different particles, how they affect the body, certain values that we should be keeping tabs on, and ultimately what all of these things mean in relation to cardiovascular disease risk. For the listeners, Dr. Carvalho, who might not already be familiar with you, can you provide us with a little bit of background about yourself before we get into the weeds?
Sure. I was born in a beautiful morning of March. No, maybe not that far back. So I went to medical school here in my native Portugal, and then moved to the U.S. Went to grad school, got my Ph.D. at Caltech, worked on Ph.D. in biology, where we were initially interested in figuring out the intricacies of the aging process. And because nutrition and food and nutrient sensing are so intricately linked with aging, we ended up doing a lot of work on the effect of different nutrients on physiology and aging and genetics, also how different genetic factors work together with nutrition to affect physiology and aging. So that was grad school. Then more recently, I worked for a few years as a research scientist in a neurobiology institute at USC, where we did a lot of work on neurotransmitters and how that affects feeling and emotion and consciousness and all that good stuff. We actually just published a paper about a month ago on that. And right now, my main passion is science communication, how to get all this wealth of information that's available out there to, average people who just want to apply it and be healthier and live healthier. So that's what we try to do on multiple platforms, and this is an extension of that.
Yeah, you do an absolutely phenomenal job of disseminating evidence-based information in an easily digestible manner. All of your YouTube videos, the content you're putting on Twitter as well, it's all greatly appreciated as there is so much confusion in this space. And per your brand, you are making nutrition simple to understand. And for this episode today, you're going to be making lipids easy to understand. This is lipids made simple.
Hopefully. We'll see. Well, I'll let the audience be the judge of that.
And while we will be, covering some of the basics of this, knowing the Muscle Memoirs audience and what they really enjoy, we're also going to be getting into the nuances of as well, and kind of getting into the nitty-gritty details of this topic. But with that being said, I think it's appropriate to set the stage with a more general concept, something that every listener is going to be familiar with in this discussion, and that is LDL cholesterol. This is a metric that's on any basic lipid panel. And I would say that, within that basic lipid panel, this is probably the most important value, the one that you should be paying the most attention to. But this is debated within the nutrition space, especially on social media. And for that reason, I want you to lay out for the audience, what are the lines of evidence we can look to evaluate the role that LDL-C is playing in the risk of cardiovascular disease? I mean, is there enough there from different areas for us to look at this and say high LDL-C is causal in cardiovascular disease?
Right. So let's just clarify, just in case somebody's not clear on what LDL cholesterol is versus LDL, because they're very different things, and they're
Yes.
very, very commonly confused, even by scientists and doctors. It's very natural to confuse these things. The scientists did not help us with the terminology. All these things sound the same. It's all confusing. So LDL is the lipoprotein, the carrier of different types of fat. So LDL stands for low density lipoprotein. And LDL cholesterol is the cholesterol traveling inside that lipoprotein. So the analogy we use in the videos is a bus and the passengers in the bus. So LDL cholesterol is a type of passenger. The analogy needs to be elaborated a little bit. You need to have a couple different buses and then different passengers within each bus to accommodate for the different types of fat. But basically, the bus would be the LDL for now, and the passengers would be the LDL cholesterol. And then triglycerides would be a different type of passenger. So the question is, what evidence points to or away from LDL cholesterol being causal in cardiovascular disease? So there's three basic pillars, and we're simplifying this a bit. There's a bit more. There's a lot of work in animals, but we'll gloss over that for now. In humans, let's say there's three main pillars. The first pillar is observational, what's called epidemiology, right? So you look at a population, you're not intervening, you're not telling them to do anything. You're just looking at their metrics. In this case, their lipid metrics. And then you're recording their outcomes. Who gets heart attacks, who gets strokes, who dies of cardiovascular disease. And then you look for statistical correlations. And when you do that, you see a strong direct correlation between LDL cholesterol levels and cardiovascular risk. People who have higher LDL cholesterol tend to have higher risk. But that's just observational. We know that can be confounded by many different factors. So you want to confirm that with what's called an interventional trial, something where you go in and you tell people to do this and do that. And ideally, you do that randomized. So later in time came the randomized controlled trials with cholesterol-lowering drugs, statins, and then later other classes of drugs. And those drugs powerfully lower LDL cholesterol, and they powerfully lower cardiovascular risk. So that would look to confirm the causality. Then later came genetic experiments, Mendelian randomization, sometimes it's called. And what you do there is you look at people who have genetically determined lower or higher LDL cholesterol levels, and you see if their risk is higher or lower. And there what you see is as well that people who have genetically high LDL cholesterol tend to have more heart disease and vice versa. So it all seems to fit together nicely. Here's the problem. These metrics all affect each other, right? They're not all independent. They're all hermetic. When you change the number of passengers, typically you're changing the number of buses as well, and the number of different types of passengers affects each other. So yeah, in that analogy, if you think about a city trying to manage their transportation system, if you lower the number of buses driving around, there's also going to be less passengers traveling in those buses because now you have less buses going around, right? And vice versa. If you have suddenly less passengers, probably you're going to cut back on the number of buses because they're just going around empty. You don't need them. The same thing happens with lipids. So those three pillars that we touched on, where we see that nice correlation between LDL cholesterol and risk, which by the way is risk dependent, it's really compelling. The problem is you also see a similar direct correlation with the number of lipoproteins. So the number of LDLs and this thing called apoB, which I guess we should define that for clarity. apoB is one protein that tags a class of these lipoproteins. So there's different families of lipoproteins, but LDL belongs to the apoB carrying lipoproteins, and those are the ones that are atherogenic. And that tag, that apoB lipoprotein, is really useful because there's only one copy of apoB, one protein per lipoprotein. So it's really like a license plate, right? It's unique and it's one copy per bus, which is really useful because then we can just measure the number of apoB proteins and we know how many of these particles are traveling around. So the number of apoB, which reflects the number of lipoproteins, also correlates really well with risk in those three pillars together with LDL cholesterol. So you, just by looking at that, you can't tell which one is guilty, which one is the culprit, right? Because you got these two people that are always in the crime scenes together. So what you need to do is you need to go look for the exceptions. where you can uncouple them, where you need to look for crime scenes where only one of the guys shows up and the other has an alibi, right? So in the observational evidence, you do what's called a discordance analysis. Fancy name, but all it means is you look at the exception, people where LDL cholesterol and apoB are not traveling together, where maybe they have high cholesterol, high LDL cholesterol, but normal apoB, or vice versa. And when you do that, you find that the risk tracks with apoB rather than LDL cholesterol, tracks with the number of lipoproteins rather than the passengers, the content. And then you do similarly for every pillar. With the second pillar, with the cholesterol lowering drugs, most of those famous drugs, the statins, the PCSK9 inhibitors, the ezetimibe, they do lower LDL cholesterol, but they also lower the number of lipoproteins. And what they do, in fact, is they modulate the function of the LDL receptor. When you increase the number of LDL receptors, these little antennae on the surface of hepatocytes, of liver cells, they capture more LDL particles out of circulation, and thereby you're reducing the number of particles in circulation, and you're reducing the total LDL cholesterol in circulation as well. But there are some drugs that play with the concentration or with the amount of LDL cholesterol content, but don't do that, but do not modulate particle number. And those drugs don't do much to risk, right? So there you uncouple that as well. So you see that lowering LDL cholesterol is only beneficial and is only sufficient to improve risk to the extent that you've done that through modulating the number of lipoproteins, not by modulating cholesterol by itself. And then the last pillar, the genetics, same thing. The people that tend to have higher, that have genetically determined higher LDL cholesterol also tend to have genetically determined larger number of LDL lipoproteins. And so there you do also, you look for that exception, and you do something called multivariate analysis, where you ask statistically which metric tracks best with risk. And again, you find when you adjust for lipoprotein number, for particle number, the effect of LDL cholesterol goes away. So when you put everything together, what this is telling us is that LDL cholesterol, it correlates well with risk. It's a useful proxy. It's one analogy we used in one of the videos is that it's the check engine light on your dashboard. So when that comes on, generally it's a good idea to take a look at the engine. It's not a good idea to drive around for a year or more with a light on. It spells trouble, but it's not perfect, right? You can imagine that the circuitry to the light could be defective and the engine could be about to blow up, but the light is not on, and vice versa. The light could come on because the circuitry is not working perfectly, but the engine is fine. So LDL cholesterol is like that. Most of the time, in most people, if there's a frank elevation, apoB will also be high. So it's a useful, and it's a useful, metrically useful proxy, but it can fail. And those are the discordant cases, which are about 25% of people, give or take, depending on the study. So it's good to keep in mind always that the real lever that you want to be pulling on at the end of the day of causality is apoB, is number of lipoproteins.
I think that was an excellent overview. So we have these converging lines of evidence, and for all practical purposes here, high LDL-C, a surrogate for, it's a metric that we use to more or less indirectly assess the actual concentrations of LDL, right? That seems to predict risk pretty well. But as you outlined, it is inferior to apoB, which is it's a more comprehensive metric. So within apoB, we're including LDL, but we're also including these other atherogenic particles, VLDLs, IDL, and for this reason, it tends to do a bit better job in predicting overall risk in individuals. And I think that that's useful for the listeners to know, because the rest of our conversation today will probably be focusing on apoB because it is more comprehensive, because it tends to do a better job, and it's probably the best metric out right now, right? I believe recently you put out on Twitter in response to a recent study on this, like, hopefully, maybe it happens, maybe it doesn't, but within the next 10 years, we should really just be measuring apoB and kind of leaving the rest of this stuff behind, right?
Uh, you'll find resistance with leaving everything else behind, but I think adding apoB to the run-of-the-mill lipid panel makes sense, and there's a push for that by a lot of leading experts, and I think that's going to happen eventually, where it's going to be something that everybody knows their apoB, and you can still have your LDL cholesterol and stuff like that. It doesn't hurt to have more information, but just I think the priority is to understand the hierarchy of these things, and that some things are more fallible than others. So when all we have is LDL cholesterol, and we can talk about the hierarchy, non-HDL cholesterol being a bit better than LDL cholesterol, and then apoB being a little better than that. We can go into those details if you want. But it's important to understand what each thing is worth, not extrapolate too much or not lean too much on something that's imperfect, because it can lead to error, especially when you're dealing with a large population. You're bound to have people that are misled and going by metrics that, in their case at least, are not reflective of risk.
Yeah, absolutely. And I kind of want to touch on some of those nuances here when people are trying to interpret these values. So you mentioned earlier that in some people, their LDL-C might be high, but their apoB is actually low. And in those cases, their overall risk is probably pretty low, which I think might be somewhat confusing to some of the listeners, since we said that these metrics are related in some sense. So could you touch on that for them, for people who might be getting the basic lipid panel, they see their LDL-C is high and they never get that apoB, and they think they're at increased risk, but maybe they're actually not.
Yeah. So for the reasons that we kind of touched on with the genetics and all this, the multivariate analysis and the discordance analysis, the current understanding is that the primary causal factor is the number of lipoproteins. You can think of it this way. What causes the traffic jams on the roads is the number of buses, not the number of passengers in the buses. Whether the buses are empty or full, if you keep the number of buses constant, right, the traffic is going to be the same. Now, in general, when you look across, like say you look at different cities, but if for some reason you can't measure the number of buses and all you have is the number of passengers traveling in buses at a certain time, that'll give you a pretty good guesstimate, right? Because yeah, it's going to give you it's going to correlate well with the number of buses on the road. So it's not a useless metric. But sometimes you're going to have exceptions where the buses are just traveling exceptionally empty or exceptionally full, and it's going to be off. Your estimate's going to be off. So it's the same thing with lipids. For most people, most of the time, LDL cholesterol will give you an estimate in the right direction, in the right ballpark. And non-HDL cholesterol, which I guess we can go into a bit more detail. So non-HDL cholesterol basically means you take total cholesterol, you subtract HDL cholesterol. So what you end up with is all the cholesterol that's being carried by all the other lipoproteins other than HDL, meaning the apoB carrying lineage, your LDL, your IDL, your VLDL, and your chylomicrons. And so those are the atherogenic ones. Chylomicrons not so much, and VLDLs, the largest ones might not enter the wall, but that's details. Basically, you're much closer to, as you explained 5 minutes ago really well, that's a better estimate than just looking at LDL cholesterol, which is just looking at your LDL pool, which is in most people, most of your apoB carrying lipoproteins are going to be LDLs, like 9-to-1 or 10-to-1. But when you have a metric that covers more of your atherogenic lipoproteins, you're better off. You're closer. It's more predictive of risk, more reliable. So non-HDL cholesterol, a little more reliable than LDL cholesterol, and then apoB a little more reliable still, because with the cholesterol ones, you're still doing this guessing game, looking at passengers and kind of guessing that the number of buses is going to be reflected. But with apoB, there's no such leap. You're literally looking at the number of buses, and you're just, you're looking right at your causal marker. But yeah, the problem is, and the confusion is that historically, a lot of the work has been done on LDL cholesterol, and that's why when you look at your lipid panel, you see LDL cholesterol, but you don't see apoB. You don't see any measure of lipoproteins directly. You all see as passengers. And so this is really confusing to people. Most of the studies talk about passengers. Most of the discourse talks about passengers, and yet here are scientists saying no, now everything's about buses. Well, you've been talking about passengers for a couple of decades. Now we're being it's throwing us off for a loop. But yeah, this is where most of the evidence is pointing. There are exceptions, and we can talk about that. Lp(a) might be an exception, but in general, everything's pointing to the number of lipoproteins being key.
To expand on the importance of the total number, and that being the primary thing we're concerned with, and then also debunking some of the the fallacious positions out there of things that do and don't matter, I want to touch on particle size. So someone might put forth, well, total number is this, but let's consider the composition of those particles. And they might go on further to posit that, well, larger particles are less likely to be trapped within the arterial wall compared to small dense particles. So for that reason, if total number is high, but it's mostly large, we don't have to worry so much about being trapped, and hence less overall risk. But it's a little more complicated than that. There, like most claims, right? There's some truth in there, but it doesn't exactly cover the whole story.
Yeah, I think that's accurate. So I don't blame people for thinking that, and it's not entirely unreasonable. When you look at the observational evidence, again, that first pillar that we talked about, you do see a correlation between particle size and risk. And like you said, people who have lower or smaller particles, smaller LDLs, tend to have higher risk. So it would be suggestive that would be protective. The problem is the same logic that we covered when we were talking about LDL and apoB, LDL cholesterol and apoB, is that the observational stuff alone can be misleading. So we need to do more confirmation. And so we have the same problem, is that these metrics all vary together. Like, it's called collinearity, right? If you think about it, there's no way to change particle size by itself without changing other metrics. It's not possible. If you take larger LDLs and you reduce them, you're necessarily trafficking around less cholesterol. So your LDL cholesterol goes down. Or if you want to keep LDL cholesterol constant and reduce particle size, you have to increase particle number. Right? So you're always stuck, because you're always, to change one thing, you have to change something else. It's just like the buses. If you reduce the number of buses traveling around at a certain time, you have less passengers traveling inside those buses. And if you want to leave the number of passengers constant and you want to build smaller buses down, now you need more buses to carry all those people. So because of this reason, you need to do a further analysis to kind of untangle the different parameters, the different confounders. And so when you do multivariate analysis on the observational data, what you see is that when you adjust for the content of the particles and for the number of the particles, the effect of the particle size generally tends to go away. Most of the analyses show that. And then you can confirm that with the genetics. Same thing, you can look at which metric tracks best. Is it genetically determined lower size, or genetically determined content, or genetically determined particle number? And again, you find that the risk tracks best with particle number, with apoB. And in fact, one thing that's come out recently in the last couple of years out of these genetic studies that's really tantalizing is that even VLDLs, which are by definition much larger than the largest LDLs, right? Even VLDLs are atherogenic, and it's now thought that they're equally atherogenic to LDLs. So all of the apoB carrying lipoproteins they represent roughly the same risk. Now, I'm not saying total LDLs versus total VLDLs, because the number, as we said previously, is very different. But particle by particle, they're equally atherogenic. So each VLDL to each LDL. And there's some speculation on why that would be and the mechanisms behind that. We can touch on that if you want. But if this is coming out of the genetics, that even VLDLs that are much larger are equally atherogenic, to posit that larger LDLs, which are kind of intermediate, you'd have to wrap your head around the fact that, risk goes up and then goes down again. It has nothing to do with size anymore, right? It's no longer explained by size. But basically, yeah, it doesn't. When you do these more detailed analysis where you try to uncouple the different factors, the particle size doesn't seem to play much of a role. Now, if people are in love with the particle size, and if they have a way to increase their particle size, I haven't seen any evidence that that's detrimental, provided that you're not doing that at the expense of increasing particle number. That's the critical caveat, right? Because that would be jumping from the pan to the fire. So if you have a way to increase your particle size, but leave your particle number constant or bring it down, I don't see a problem, off the top of my head. But to suggest that having increased apoB is okay because the particles are larger, the bulk of the evidence is just not pointing in that direction. It's pointing in the opposite direction. So I would alert people to heed apoB and focus on that in terms of protecting themselves and lowering their risk.
Hey guys, Mike here. If you're interested in learning more about how to maximize your health, body composition, and performance, head over to hammerawayfitness.com, where you can sign up for coaching or even just schedule an hour consult with me to get some of your training and nutrition questions answered. Also, if you enjoyed this episode as much as I did and would like to further support the growth of the Muscle Memoirs podcast, you can give a donation to the link in the show notes, leave us a review, and or share this episode with your friends, whether that be dropping the link in a group chat or putting a screenshot in your Instagram story. I truly appreciate it. Fantastic. Yeah, I mentioned prior to going live that I was brushing up for our conversation by reading the review by Snyderman in 2018. And exactly to your point, a quote that stuck out to me in that paper is that when we look at particle size, apoB particle size, we might say that, well, small dense particles more likely to be trapped than the larger ones, but the larger ones do contain more cholesterol. So when those do get trapped, there's going to be a higher relative damage for each one that gets in. So all of these points are tying together here really nicely. To further go on about apoB and how it is a comprehensive metric. If you can only choose one, you should probably get apoB. I think it's also worthwhile to touch on unique circumstances where apoB becomes an even more reliable metric. So one thing that comes to mind for me is in the case of hypertriglyceridemia, right? So in these cases where it's unique and we have all of these other things going on, apoB becomes even more useful. And perhaps you could touch on to the listeners why in that case apoB is more worthwhile, and anything else that comes to mind where, yes, apoB is generally the way to go, but there might also be unique contexts where you should probably go out of your way beforehand to get apoB because we know for this unique case all the time, this is definitely the way to go.
Yeah, so with triglycerides, the story is very similar to LDL cholesterol, where you do see, when you look at triglycerides in isolation, you do see a nice correlation in all the pillars. So people with high triglycerides tend to have higher risk. The pharmacology, the randomized control trials with the lipid lowering drugs is a bit more heterogeneous than the statins. So the cholesterol lowering stuff, you do see in some trials, but it's not as consistent. But in trials where you lower triglycerides dramatically, you do see lowering of risk and lowering of all-cause mortality. And then with the genetics, the same thing. If you look only at triglycerides, people who have higher triglyceride levels tend to have higher risk. But similar to LDL cholesterol, when you then analyze further and you try to untangle it, you see that the particle size, the particle number, basically trumps triglycerides as well. So to go straight to the genetics is probably the one that's been teased apart the most. There's a study by Brian Ferris, I think 2019 in JAMA, where they looked specifically at this. They had one mutation that played with the LDL cholesterol numbers, another mutation that played with the triglyceride numbers, and both of those tracked with risk. But then they asked, if we adjust for a particle number, do those go away? And both of those effects went away when you bring into the equation the particle number. Now there's a slight uncertainty. There's two major studies that did this exact experiment, and one shows no effect of triglycerides after you correct for particle number. Another one by a lab in Finland shows a residual 12% remains even after correcting for apoB, which would mean that there's a sliver of effect that is attributable to the triglycerides by themselves. And I've actually talked to one of the guys from that lab, and he thinks that it's legit. I think it's still up in the air, but in either case, it would mean that still that apoB would be responsible for the bulk of the risk, and then you may or may not have a small amount of risk left with triglycerides, which would mean that you'd still focus on getting your apoB to healthy levels, and then if you want on top of that to get your triglyceride to healthy levels, I mean, nobody's going to argue with that. But apoB would still be, the one that would give you the most bang for your buck. And then in terms of exceptions, you were pointing to, you were touching on exceptions. Yeah, Lp(a) would be a possible exception. I don't know if it's completely established, but I've definitely seen several studies that suggest that Lp(a) could be an exception, where it could be even more atherogenic than your run-of-the-mill apoB carrying lipoprotein. And Lp(a), just in case people are not familiar with it, is a subset of LDL particles. But in addition to the apoB tag, it has another tag, another protein, that's the apolipoprotein a. And they are atherogenic. I don't think there's any doubt about that. But in terms of relative atherogenicity, it's possible that they're even nastier. And that's one idea, is that not only are they atherogenic in the strict sense, but they could also be pro-inflammatory and pro-thrombogenic. So it could be kind of a triple threat there. And that would make them, even more problematic than just the number of those particles might indicate. The good news is Lp(a) doesn't represent a problem for most people. It's genetically determined. You either have it or you don't. And in fact, you only need to measure it once in your life. And if you don't have measurable numbers, or if they're really low, you don't need to worry about it ever again, pretty much. If you do, on the other hand, the minority of people who have elevated Lp(a), and this becomes a problem, especially in people who already have their apoB under control and all that, but they still have residual risk. Sometimes it's due to Lp(a). And for that, there's both lifestyle and pharmacological interventions that have shown some results, and there's some new drugs that are being tested as well to address Lp(a) specifically, because that's a newer thing. It's a new kid on the blocks, but there's a lot of exciting stuff coming out of Sam Tsemikis' lab, and others are doing a lot of interesting work.
Excellent. So far we've touched on LDL-C, apoB. You roped in triglycerides there, and also mentioned the deadliest particle you probably never heard of, Lp(a). And I think to round out this section of our conversation, it would be valuable to touch on HDL, the quote unquote good cholesterol. And perhaps, a shout out to the keto members of Nutrition Twitter. I think it's worthwhile to mention, where does HDL stand in predicting overall risk, right? So we mentioned that high LDL-C, high apoB, more or less causal in cardiovascular disease risk. But for those who have a high LDL-C, they might mention that, well, my good cholesterol, my HDL-C is also extremely high. So that must mitigate risk to some degree, right? How would you respond to someone who puts that forth?
I would follow the same logic we've already followed like 2 or 3 times in this conversation. So you basically have to look at the evidence, the totality of the evidence, right? You look at the observational evidence. You don't dismiss that it has value, but then you also look at everything else that we know, all the causal tests, and then you put everything together and you see what the total landscape is likely to be. So similar to the particle size, it's understandable that people rely on or believe that HDL cholesterol might be protective because the associations are there very clearly. All the way back to Framingham, you see an inverse correlation, very strong. You see people who have lower HDL cholesterol levels tend to have higher risk. And it's a powerful correlation. You see it consistently in epidemiology. The problem is, and that created a lot of excitement. People in the field were very excited about it. HDL cholesterol, that's where good cholesterol, bad cholesterol came from. Fortunes were invested in coming up with drugs that raised HDL cholesterol that hopefully would be protective. Dozens of randomized controlled trials were run, hundreds of millions of dollars per trial. We're talking a massive, colossal endeavors trying to test this, and no doubt rooting for it to work. The problem is causal tests have consistently been a dud. So the clinical trials, the randomized controlled trials, there's been at least 39 that I know of. There's a meta-analysis that looks at 39 randomized controlled trials, several different drugs, at least 3 classes of drugs, 3 different drugs that do effectively raise HDL cholesterol, but you don't see an improvement of risk. The risk doesn't come down. And then the genetics, same thing. When you look at HDL in isolation, you do see a correlation with an inverse correlation with risk, which would appear to be protective. But then when you bring in apoB and these other metrics, that effect goes away. So it's completely abrogated. So when you put everything together, what it's very consistently telling us is that it's a marker. It can be predictive in a population setting. That's why this is confusing and it's hard to explain, right? Because it's not, you can point to the studies and say, look, you have a better correlation with HDL cholesterol in this population study than even LDL cholesterol. So how can you say that this isn't protective and isn't causal? And it's not intuitive, right? It's tough for us to see this, but you can have correlations with things that are really strong, but then do not have a causal link. I mean, one analogy would be if we're trying to figure out what causes lung cancer, and let's say we don't know yet, and maybe we suspect that it has something to do with smoking, but we're not quite sure. And so we go into people's houses, we do an inventory of their lives, and then we follow them and we see who gets lung cancer. We find out that there's a strong correlation between people who own ashtrays and people who get lung cancer 20 years later. So now I say, well, or you tell me, man, you're smoking a lot, aren't you worried? And I say, no, but I gave away all my ashtrays, so I'm protected. I'm no longer at high risk. It seems silly in this setting, but what I'm doing is I'm taking a correlation that is really strong and I'm extrapolating causality, right? If the causal links are not clear in our heads, it's not hard to make that mistake. And that is what's being done in general with HDL cholesterol when we assume that it's causal and having it high is going to be protective. Now, I think it's reasonable to say as well that although the evidence is very consistent in pointing against the causality there, first of all, we were talking about major atherosclerotic cardiovascular disease. I'm not ruling out that HDL cholesterol could have a protective effect or a positive effect in immune function, maybe in other peripheral artery disease. There's some indication that might be the case, but not with these events, not with heart disease, not with myocardial infarction, with ischemic strokes, these major things that we're worried about. And so to posit that having high LDL cholesterol, or even worse, high apoB, that would be somehow mitigated by having high HDL cholesterol is just incredibly difficult to justify that based on the totality of evidence. The other thing to say is that we are talking about HDL cholesterol. We're not ruling out that the particle itself, HDL, might have a protective effect. It hasn't been studied as much. there have been some experiments, and this is actually another pillar with HDL. In some ways, we have more evidence. There are some mimetics that people have used where it's kind of an artificial lipoprotein that's made synthetically, and then it's injected into people. And they showed that it does sort of replicate the reverse cholesterol transport function of HDL. But then when you inject it into people, it doesn't lower risk. So, the function of HDL having some protective effect hasn't been ruled out, but the simple idea that just raising HDL cholesterol is going to protect me and make up for high LDL cholesterol or high apoB, I would highly discourage people from thinking that way. I wouldn't encourage anyone I cared about to go along those lines. It's just really dangerous. And I also see incredible agreement on this when I interact on Twitter with these leading experts, and they're actually more categorical than I am when they talk about this. Tom Dayspring or Sam Samikas, they are so clear on this. They say we don't even look at HDL cholesterol anymore. And by the way, they extend this logic to the ratios. This idea, almost not a day goes by that somebody doesn't ask me if triglycerides over HDL cholesterol is not a better metric than LDL cholesterol. What you do when you take a metric that isn't reliable, that isn't reflective of, that isn't causal, and you throw it in a ratio, you end up with an unreliable ratio. And it's not hard to see that if my HDL cholesterol shoots up through whatever lifestyle change, but nothing else changes, that ratio is going to look better, but I've done nothing causally to protect myself. So yeah, I see these people being incredibly categorical and clear about the fact that they don't even pay attention to HDL cholesterol anymore. Again, I would say follow apoB.
I appreciate you starting your response by highlighting, hey, we have a recurrent theme here with the answer to all of these questions. You mentioned in the beginning, well, we'll see what the listeners have to say about, how simple we are making lipids in this conversation. But regardless of how closely the listeners are following along with the specific research and how it's evolved over time, I think they will be able to practically take away from our chat. There are all of these variables that people like to throw out, which might be confounding our confidence in these metrics, right? What about the particle size? What about high HDL? What about low trigs? Doesn't matter. High LDL-C, high apoB, we have a risk that needs to be addressed.
I wouldn't go as far as saying it doesn't matter. If triglycerides are frankly high, I wouldn't ignore that. I think I see LDL cholesterol and triglycerides as somewhat similar, fundamentally similar. Yeah, you might argue that one is a better, tracks better with risk or the other, but I see them as both useful check engine lights. Like if on your dashboard, instead of one check engine light, you had 2 or 3 for different parts of the engine, maybe, right? That's how I see LDL cholesterol and triglycerides. If somebody is walking around with triglycerides of 400 and their LDL cholesterol is really good, I don't think that's good. But in reality, that probably reflects that their apoB is not ideal, even though the LDL cholesterol is. It could be that their VLDLs are really high and their LDL fraction is normal, right? So I wouldn't ignore that metric. I think what's important to understand, and this is how we also approach a lot of the confusion in our videos, is to get people to understand that looking at totality of evidence is really crucial. And almost all of the confusions around nutrition and lipidology come from looking at just one piece of the puzzle and ignoring everything else and trying to extrapolate, right? It's like looking at a corner of a painting and seeing that it's greenish and claiming the painting is all green, when in reality, 90% of the painting is red, and that corner is not even green, it's just dirty, right? But if that's all you look at, you could be forgiven for thinking the painting is green. And so this is very misleading and very, it's not, I'm not saying that people do this on purpose, but it's very convincing if this is all you show them. We have one video where we explain this with bags of evidence. We broke it down in 3 bags of evidence, and one is the observational studies, one is one is lab experiments, one is observational trials, and one is randomized controlled trials. So the idea is that a lot of times the confusion comes from comes from somebody showing you just one bag and telling you, here's the data. Clearly, it's pointing to the left, but maybe the other two bags are pointing strongly to the right. And another concept to add to totality of evidence is hierarchy of evidence. All the experimental approaches don't weigh the same. Everything else being equal, a causal test weighs more than an association. There are caveats to that, and there's nuance to that. A lot of times this gets oversimplified in discourse on social media. We don't throw away observational evidence. And in some cases, observational evidence can even weigh more than an RCT. There are cases like that. But as a rule of thumb, everything else being equal, the causal test is going to be more compelling in terms of causality, which is usually what we want to determine. So it's very important that we make sure that we're looking at everything that's available and that we are carefully assigning the right weight to each experimental approach. And a lot of the confusion comes from kind of bungling that process.
Yeah, I love that. And I appreciate that context in regard to a unique scenario where LDL-C is low, but triglycerides are high. There is a risk that we need to address there. I guess I would then pose, for the listener, like, is there a situation where apoB is high, but because of other factors, we're not at high risk in this equation? Does that exist?
Not at the top of my head. Generally,
Okay.
I'm sure you could find an exception because in
Right,
medicine,
right.
but in general, if your apoB is high, you're generally going to be at high risk. And maybe I don't know, maybe a professional lipidologist could come up with an arcane
Right.
situation that they saw once. But in general, that would be according to the current knowledge, that would be the best metric of risk. So now, of course, different people can handle different amounts of insult, right? So yeah, you could have somebody with high apoB that never has any manifestation, that never has a heart attack, that where heart disease never becomes a problem. There's always individual variation, but in general, yeah, that population is going to be a high risk. Yeah, so but even there, you would probably consider other factors as well. You'd consider family history, you'd consider overall health. You'd probably look at all these things to really delineate the overall risk of this person and kind of the strategy, the therapeutic strategy. But then the higher those numbers go, the more of a concern it is, and the less you'd temper it with other things. I mean, if your apoB is borderline and you have no family history, you're really healthy overall, maybe you wouldn't worry too much. But if your apoB is sky high, even if you don't have a family history, even if you're otherwise healthy, probably it's worth trying to moderate it to the extent that you can. We all have different potentials to, we can't all get the numbers to stellar levels, but to the extent that you can with lifestyle, and in some cases, depending on risk with medication, I think it's worth addressing.
Excellent. I think that was a nice and simple takeaway there. Dr. Carvalho, I know we're coming up on time. I want to get to maybe one question for the relationship between a specific food and cardiovascular disease risk. And, in regard to selecting one food in this equation, I don't think there is one that is any better than eggs. When it comes to controversy and whether a food is good or bad, eggs seems to be at the top of the list. Today we have a new paper that comes out and it says, maybe eat one egg per week. I wouldn't even risk that. If you're willing to trade off 5 years off your life, you can do it. And then we have another where it's like, yeah, you could eat a carton a week and you're probably fine. And you probably even experience some benefits from it because there are some nutrients in eggs that aren't that prevalent in other foods. So it can be really beneficial. When you consider the totality of the evidence, what we have available, where do you stand on eggs in the relationship with CVD risk? Are they a food that you're concerned about, that people should be limiting? Where's kind of the threshold in your mind here?
So this is the hardest thing about nutrition, because there's heterogeneity in the studies and people are understandably confused because one study says one thing, the other study says another. And usually when you see that heterogeneity, what that points to is context dependence. assuming that the studies are all at a decent level of quality and are not making a basic mistake, which the heterogeneity around eggs is so clear that that's not what's going on. I think what's going on is you have context dependence. You have different amounts of eggs, at baseline, and then different amounts in the intervention, or the quartiles or the quintiles if you're looking at an observational study. You have different background diets on which the eggs superimpose. You have different baseline lipids that people then add eggs to. You have individual variation, you have different populations. So all of those moving pieces make it harder to isolate one factor. And they explain some of the variation. So the broad strokes is any food that is relatively high in saturated fat. Eggs are not as concentrated in saturated fat as, say, butter or a fatty cut of red meat. So in that animal world, they are a less saturated fat rich food. But any food that is relatively rich in saturated fat and very rich in cholesterol can potentially raise your lipids and can potentially raise your risk. So what I would disagree with is the two extreme positions. And that's not just to appear like a moderate, it's because I don't think they're accurate. When people say eggs are bad, period, I don't care how many you're having. If you have a stellar diet with fruits and vegetables and amazing, and you're a healthy individual, young, everything is solid, and you add one egg a month, you're damaging your health. I completely disagree with that. On the other end of the spectrum, we have people saying eggs are fine, period. There's nothing ever that could be wrong. If we have an individual with hypercholesterolemia, just off the charts, dyslipidemic to high heaven, and this person is eating 7 or 8 eggs a day because they think they quote unquote need the protein, that's not a problem. I disagree with that as well. There's room for improvement there. So those are clear because they're extreme cases. The problem is the middle, right? The middle is where the nuance comes in. And it's really hard to tell somebody, because what everybody wants to know is exactly how many eggs, exactly how many bites can I have right before my risk shoots up. I want to know precisely how much I can get away with and not step on that line. And that's impossible to say because of all these moving pieces. There's individual variation. Some people, if the both of us eat the exact amount of the same amount of eggs in the same background diet and everything else the same, our lipids won't be the same. We have different genetics, and our risk won't be exactly the same. So it's really hard to individualize. All you can give people is the broad strokes. So what I like to focus on is not so much the foods to avoid, it's the foods to favor. And what's a general, if we have a clear picture of a healthy dietary pattern, a health promoting dietary pattern, there's wiggle room there. And I'm less worried about whether people add an egg or add a piece of chicken or add a whatever it is, or add some ice cream once in a while. I'm not worried about that. What I'm worried predominantly is the foundation. And I would say that that's a foundation with a lot of fruits and vegetables, a lot of unprocessed plants. If you have some legumes and whole grains, great. Easy on the saturated fat, total, easy on the ultra processed foods, and easy on added salt. That would be an easy, kind of simple picture of a health promoting dietary pattern, a home base, if you will. From there, there's plenty of wiggle room. Some people are going to want to have some red meat with that. Some people are going to want to have some cheese. Some people are going to want to be completely vegan. Some people are going to want to be low fat. Others are going to want to be low carb. All of those variations are compatible with health, provided that those basic buttons are being pushed that we listed, right? The basic dietary pattern. With cardiovascular disease, we have an advantage over other diseases, which is that we have a control panel. We can refer to this feedback mechanism, which is our lipids. With other things, it's much harder to do that. How do you know if you're at risk for, Alzheimer's or something like that? Yeah, you can look at your apoE type, but it's harder. With cardiovascular disease, we can almost in real time look at our lipid metrics and get a decent guess of where we are. So if your lipids look stellar, what you're doing is probably pretty close to optimal for you, and you don't need to worry much. If your lipids are a mess, if you're completely dyslipidemic, there's probably room for improvement. There's probably room for tweaking, for maybe moderating the saturated fat. And if you want to stay high fat, you can. this is another myth that you need to go low fat and high carb. You can, but not necessarily. You can go high fat and have really good lipids. That's been shown in the literature. What you need to do is play with the quality of the fats. It's not so much the macronutrients. So you'd go a bit more on the unsaturated fats end of the spectrum, maybe a bit more nuts and seeds, a bit more avocado, olives, some vegetable oil, some fish, whatever you want to introduce into your diet. So bottom line is I would say every 100 miles of the trip or so, you take a peek at your dashboard, at your check engine light. And if it's on, you do a bit of course correction. If it's off, it's a sign that you're heading in the general right direction.
I think those are really useful takeaways when it comes to any controversial food, right? Regardless of whether it's eggs, red meat, full fat dairy. These are some prudent points to consider. And for some more details, if you are checking all of the right fundamental boxes and there are some issues with specific lipids, you have some great videos further breaking down some considerations that are worthwhile to trial to fix those specific issues. But Dr. Carvalho, thank you so much for your time. This has been a wonderful discussion. I know the listeners will get a ton out of this one, and it will go really nicely with our episode with Nick Hebert, talking more about saturated fat and polyunsaturated fats. So,
yeah, I got to listen to that one. He's awesome.
Yeah, absolutely. He was great. Dr. Carvalho, for the listeners who want to go learn more about you and support you, where can we point them towards?
So our YouTube channel is Nutrition Made Simple. That's where we try to publish videos weekly or bi-weekly when we can, when we're feeling confident. And we basically try to touch on all these different questions and concerns and confusion on nutrition and lipids and all this stuff. So that's Nutrition Made Simple on YouTube. I'm on Twitter, and I'm at Nutrition Made S3. If you search that on Twitter, or if you search my name is a mouthful, so that's hard to search. My last name is like a Wi-Fi password. And then what else? Facebook. We have a group on Facebook, Nutrition Made Simple as well. If you search that on Facebook, you'll find us. Those are my three main platforms for social media right now. People have been pushing me to get on Instagram, and I've been resisting it. So we'll see. Maybe one day.
Yeah, we'll have to get you on Instagram, but the links for all of those platforms will be in the show notes, everyone. Highly encourage you checking out Dr. Carvalho's content. If you like this chat, you're going to love everything he's putting out. But that does it for another episode of the Muscle Memoirs podcast. Thank you so much for listening.